0, 1, 2, 3, 4, 5, 6, 7, 8, 9.
What the hell is that?
It's a sine graph.
What?
I'm a math fairy, and a sine graph is a repeating graph.
But test about it. Would you mind teaching me?
Sure, I'll take you somewhere. So where are we, Mr. Fairy? We're in the fairyland. I'm gonna train you how to do math. I'm gonna teach you, son.
But first, let me take a selfie.
To understand sinusoidal graphs, we must start from the unit circle. This is the x-axis, this is the y-axis. So at this point, we have the coordinate of this point is actually 1, 0, and the coordinate of this point is actually 0, 1. So by this time, you should know that the sine of a certain angle will resemble the y-coordinate. It's a unit circle. So for example, at this point, the theta would be 0, or 2 pi, or 4 pi, or 6 pi, 8 pi, 10 pi, 12 pi. And then, therefore, sine theta resembling the y-coordinate would actually be 0. Nice. So moving on to this point here, 90 degrees, or sine pi over 2. So what is sine pi over 2?
1.
Yes, the y-axis. You're learning. Nice. So moving another pi over 2, we come to this point, which is negative 1, 0. So sine of pi over 2 plus half pi, would actually be 0. Nice, you're learning. Nice. So moving on another half pi, we now come to sine 3 pi over 2, and the coordinate here is actually 0, negative 1. So this would be
Negative 1.
nice. And then we come back to 0. As you can see, you can get a general idea. It goes from 0 to 1 to 0 to negative 1 to 0 to 1 to 0 to negative 1 to 0 to 1 to 0 to negative 1 to 0. So you can feel that it's kind of like going back and forth, you know? Going back and forth. So, if I apply sine x equals y, so what do you feel? So what do we have here? Sine x and y. So let's say x is theta. So theta, we have 0, we have pi over 2, we have pi, we have 3 pi over 2, 0, half pi, 3 pi over 2. And the y-coordinate would be 0, 1, 0, and negative 1. Easy. Is it easy?
Yes, I'm starting to understand.
Nice. So if we plug this in to the x and y axis, so here we have 1, here we have negative 1, and here we have pi over 2, pi, 3 pi over 2, and 2 pi. Easy.
Easy.
So from pi, we just plug the numbers in. 0, 0, pi over 2, 1. Yeah, pi 0. 3 pi over 2, negative 1. And 2 pi would come back to 0. connect the dots. And here, we have a portion of the sine graph. So as you can imagine, the sine graph actually goes on and on and on. So it's like a wave.
I see.
You know what I'm saying? Yeah. So now we're moving on to the cosine graph. So we're still starting from the unit circle. The coordinates here. X-axis, y-axis, 1, 0, 0, 1, negative 1, 0, 0, negative 1. So as you can imagine, if the sine graph resembles the y-coordinate, what does cosine resemble? The x-coordinate, right?
I see.
Yeah.
I knew that.
So for example here, cosine 0 would be 1. Cosine pi over 2 would be 0. Cosine pi would be negative 1. And cosine 3 pi over 2 would be 0. So we applied that. So we're going to apply this to the xy axis. So as you can see, cosine 0 out here will actually be 1. Cosine x equals y. So if x is 0, y equals 1. If x is pi over 2, y would be 0. If x is 3 pi over 2, pi, and y would be negative 1.
Yep.
And 3 pi over 2 will be 0. So if you graph this, it will actually be like that. Now, we have pi here, we have 3 pi over 2, and we have the 2 pi. So 2 pi will actually go back to 1. Now this is a complete period of the sine graph. So as you can see, the graph actually moves on and on, exactly like the sine graph, but starting at different points. Okay, so now let's be more complicated, okay?
Okay.
So y equals a sine bx plus c plus d.
Yes?
And let's start with a here. Y equals a f of x. So this a here will actually stretch or compress the graph. Make sense?
Yes.
That's common sense. So if we're talking about y equals a sine blah 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 blah, this a has the same effect. It determines the amplitude of the graph. Now we're moving on to b. What does b do? Well, the b here actually determines the period.
I see.
But it's not that simple. It's actually 2 pi over b, absolute value, equals the period. So for example, if we have y equals sine x, it will actually be 2 pi over 1, which is 2 pi. So the period of a normal sine graph would be 2 pi. You already know that. But, however, if we have sine 2x, and we plug the numbers in, 2 pi over 2 equals pi. Then the new period will actually be pi. So the new graph will look like this. And that would be half pi.
Oh.
That would be sine 2x.
May I have a paper, please?
Now, we're going back to y equals a sine bx plus c plus d. Now, c is a bit more complicated, so I'm going to extract the b from the parentheses. A sine b x plus c over b plus d. It should be a bit more clear here that c over b determine the phase shift.
Uh-huh. I think I'm starting to get it.
Yeah, simply put, phase shift is the horizontal shift of the graph. Now, if we have y equals sine x plus 1, the whole graph will actually shift to the left for 1 unit. Does that make sense?
Yep. This one?
Now we're getting back to y equals a sine. As you can see, it's starting to rain in fairyland. Bx plus c plus d. And we're starting from a d here. D, what is d? Typically reminds you of vertical shift, right?
Yep.
Exactly. So if we have y equals sine x plus, let's say 3, the whole graph is actually going to move 1, 2, 3.
Oh, upwards.
3
by
units.
3 units. Oh,
Exactly.
I see.
Cool. So for example,
I didn't know fairyland rains a lot.
me neither, man. There might be climate change. Oh my gosh, man.
Okay.
We gotta stop this
Could you
CO2.
please teach me? I have no time left.
Y equals sine x plus 3. Let's plug this in. So we're starting from y equals sine x, 2 pi, 1, negative 1. It's going to roughly look like this, but if we move 3 units up, this is 4. 1 plus 3 equals 4, negative 1 plus 3 equals 2. So we're going to have a graph which generally looks like this. It's going to move up 3 units.
Ah. So, Mr. Fairy, what about cosine graphs?
So if you're talking about y equals a cosine, parentheses, bx plus c, parentheses, plus d, it's basically the same thing. A would still be the amplitude, and b will actually be the period, and c will actually determine the phase shift, which is c over b, and d will be the vertical shift.
Uh-huh. That makes sense.
And welcome to my fairy realm.
Yep, it seems nice. Thank you very much.
You're welcome. Your training is complete.
Thank you.
You have earned your math wand.
Thank you. Oh wow, I'm back in school.
And we changed clothes.
Yeah.
Now, you've got a test, buddy.
I better be going. Thanks, Mr. Fairy, for everything. Bye.
I'm sure you'll ace it.
Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9.